Hello viewers, today we are going to look at how to handle items in the lower secondary curriculum. Specifically, we are going to focus on mathematics, and before us we have an item that comes from section A, and section A of UNEB final exam for senior 4. It comprises of 3 major topics, that is numbers, patterns, and algebra. So today we are lucky to have one, and we shall see how we can respond to this scenario or to this item. So before we go on, let's understand what the item is about. The item is saying, Mr. Alex, a seasoned bus driver at the new taxi park, was hired to transport 377 students for the field trip from Okono to Entebbe. When the geography teacher inquired about the best route, Mr. Alex expertly outlined 2 alternative routes, ensuring a smooth and informed journey from Okono to Entebbe. The shorter route takes 2 hours and 26 minutes to complete, with the driver maintaining an average speed of 54 kilometers per hour for X kilometers and 37.5 kilometers for the last Y kilometers. The longer route, which is 5 kilometers longer than the shorter route, takes the driver 2 hours and 12 minutes to complete at an average speed of 60 kilometers. And they are telling us that the driver also charges a fare of 1,000 shillings per student per kilometer. And now they are tasking us to create 2 mathematical models involving X and Y, which can be used to analyze in the analysis of the two routes. So for us to form these 2 mathematical models, we need to first of all write down what we have been given. Then from there we can go ahead to formulate the mathematical models or equations. So starting from the shorter route, let's write down what we have for the shorter route. For the shorter route, the time taken is equals to 2 hours and 26 minutes, which is equals to 2 hours. If we convert this 26 minutes to hours, it will become 26 over 60. We divide the minute by 60 to change it to hours. So this will leave us with total time for the shorter route to be 73 over 30 if you work out. So the whole of this would be now hours. The reason as to why we are changing the time to have minutes is that our speed is having kilometers per hour. So we need to unify the units for time and speed to be the same. So from there, what else are we given? We are given speed, but for different distance. So for X, the speed for X kilometers was given to be what? Was given to be 54 kilometers per hour. Then the one for y was given to be 37.5 kilometers per hour. Is that all? Yeah, that is all we have for the shorter route. Then let's read the longer route. The longer route, which is 5 kilometers longer than the shorter route, takes the driver 2 hours. So if we write down what we have been given for the longer route, we have the speed. The speed is given by, it is 60 kilometers per hour. Then we also have the time. The time is given to be 2 hours and 12 minutes. So we shall still convert these 12 minutes to hours, and that will give us 2 hours .12 over 60. When you try to reduce this will give us 11 over 5 hours if you simplify that. So from this information, we can now be able to get the total distance of the longer route. Then we relate that will now give us the first model in terms of the distance of the shorter route, which is x kilometers added to y kilometers. So if we do that, it means we shall get now the total, the distance for the longer route. How are we going to get the distance for the longer route? It will be, because remember, distance is given by speed. Remember, distance is given by speed times what? Multiplied by time. So if we do that, it will give us what is our speed for the longer route. It is 60 kilometers. So we shall have 60 multiplied by 11 over 5. And this will give us 12. This will give us 132. This will give us 132 kilometers. Now, knowing the total distance of the longer route will help us to get the first equation or the first model that we want. Remember, the shorter route is split into two. We have the one x kilometers and y kilometers. But also remember the longer route. So our first model shall be from the distance, the total distance that we have for the longer route. Remember, our shorter route is equal to what? X kilometers plus y kilometers. But from this statement, they are saying that the longer route, which is 5 kilometers longer than the shorter route, takes the driver 2 hours. So it means if we have the distance for the shorter route to be x plus y, to get the distance of the longer route, it will be adding 5 onto the distance of the shorter route. So we have already calculated the distance for the longer route, which is 132 kilometers. So from that, our first model, therefore, our first model will be, we have now x plus y plus 5 kilometers is equals to 132. Because the whole of this gives us the total distance of the longer route. That's why from the shorter route, if I add 5, I'm now able to equate it to this distance that we have found, which is 132. Collecting right terms, taking 5 the other side, we shall remain with x plus y is equals to what? Is equals to 132 minus 5, giving us our first model to be x plus y is equals to what? Is equals to 127. So this will be our first model. Now, where are we going to get our second model from? Our second model, or the second equation, will now be in terms of this total hours of the total hours taken to travel the shorter route. Remember, from the shorter route here, what we have is the time taken, and we also have the splitted or the distance x and y kilometers. So from still this formula of distance is given by what? By speed multiplied by time. We can still get now what? The time by dividing through by speed. So it means for us to get the second model, our second model shall come from the total time taken to travel using the shorter route, and we say that from time is equals to distance divided by speed. Then what is our total time for the shorter route? It is 73 over 30 hours. So 73 over 30 is going to be equals to the distance. We have two. We have x kilometers and y kilometers with their respective speed. So the first one is x, when we divide it by the speed, which is the 54, then plus, we now go for the one for y, which is the y divided by 37.5. Now, ideally this would be our second model in terms of total time taken to travel the shorter road. So we can try to simplify this, and we get a clean model. So here we shall have 73 over 30 is equals to, this is x over 54 plus this denominator here, I can write it as y divided by 375 over 10, which if I simplify further, will give me x over 54 plus 10y over 375. Then from here I can now get the LCM of 30, 54 and 375, of which that would be a task to you to get the LCM of these three numbers. So the LCM, if you calculate it out, it will be 6,750. So we shall multiply through everything here by this LCM such that we don't have these denominators. So if we multiply here, we shall have 6,750 times 73 over 30 is equals to 6,750 times x over 54 plus 6,750 times 10y over 375. Then if we try to simplify this further, we shall have 6,750 times 750. The first one here we shall have 16,425 is equals to this will give us 125x plus, if we multiply that, it will give us 181. So our model now therefore become 125x plus 180y is equals to 16,425. So this will become now our second model. That is, the first model is in terms of the distance, then the second model will be in terms of time. So we shall have x plus y is equals to 127, and 125x plus 180 is equals to 16,425. And that will now answer this first task of what? The first task of creating model. So it will take us now to the next task, that is to help Mr. Alex by revealing the hidden values of x and y from the equations in A and B. So for us to do this, we have two equations, equation 1 and equation 2. So we are going to solve that simultaneously, simultaneously.